Are you interested in finding the most chemistry related documentary you have ever seen? Well, you're in luck, as I'm here for you.
Good day, everyone who's watching. I am Sean Chadlor Iabera, and this is my documentary. This documentary is about the deterioration and decomposition. Since our subject is chemistry, we will also tackle the chemical changes or chemical reactions behind it. As for my prime example is the Malabar spinach, or also known in the Philippines as alugbati. However, we will use its fruits since it deteriorates and decays easily once removed from the plant rather than its leaves because of its thickness and because proven by my experiment that I will show later. Now, before we head on to this experiment and what things I might mention, let's tackle first what are the causes or reasons of deterioration and decomposition of fruits. Since you know the basic meaning of deterioration and decomposition, I won't be giving out its definition. And now, and we will also tackle what are the chemical reactions behind these. Moving on. Show! According to postharvest.nri.org, it says that deterioration of fruits by chemical change are caused by rotting by fungal and bacterial pathogens that are often the indicative of physical change or physiological deterioration. There are more things about deterioration of fruits. However, I've only focused on the chemical change, but if you're willing to learn more, I can provide you links if you ask for this topic or others. Moving on to decomposition. According to www.leaf.tv, food or fruits decompose like any other organic matter. And as I mentioned earlier, bacteria and fungi are responsible for decomposition. Also, oxygen and moisture all convert plant matter back to basic organic soil nutrients. Given the deterioration and decomposition of fruits, let's continue by talking about what are behind these stinky, rotting details. Let's go! Before we head on to the reasons and causes of such occurrences, let's talk about what is the chemical reaction of this topic. We all know that decomposition is under the decomposition reaction, in which one reactant breaks into two or more products. For example, the decomposition of hydrogen peroxide to water and oxygen. As most of you don't know, there are actually a lot of factors according to www.fao.org. There are 5 changes that affect the deterioration of fruits, which are: first off, we have enzymatic changes. Enzymes which are endogenous, meaning it is the growing or growth from deep tissue, an example, bacteria, fungi, and etc. To plant tissues can have desirable or undesirable consequences, since we all know now that bacteria and fungi are responsible for the growth and ripening of fruits, having too much will ruin one. Next off, we have the chemical changes, and under it, we have sensory quality and nutritional quality. But what are these terms? Well, sensory quality is the texture, flavor, aroma, and visual qualities of a fruit. And nutritional quality is the value of the product or the fruit for the consumer's physical health, growth, development, reproduction, and psychological or emotional well being. Okay, under sensory quality, there are two major chemical changes which occur, and these are lipid oxidation and non enzymatic browning. Lipid oxidation is a radical initiated process leading to oxidative deterioration of polyunsaturated fatty acids, according to journals.lww.com. In a simpler meaning, this process is a highly complex free radical reactions between fatty acids and oxygen, which results in the degradation of our lipids. But what about non-enzymatic browning? It is simply the chemical process that produces a brown color in foods without the activity of enzymes. Chemical reactions are also responsible for changes in the color and flavor of food during processing and storage. For nutritional quality, we have 4 major factors that affect nutrient degradation. We have light, oxygen concentration, temperature, and water activity. Now, these factors are self explanatory. Moving on, we have physical changes These are the changes that involve state of matter and energy. No new substance is created during a physical change, although the matter takes a different form. The size, shape, and color of matter may change. Physical changes occur when substances are mixed but don't chemically react. Under this, we have one major factor, which is the absorption of moisture. It doesn't only apply to where the fruit is packaged, it also happens to its environment, whether that place has high or low humidity. For the last change of his topic, get it? Change? Anyway, this change involves alters of genetics, either taking place in a small population or inherited over a few generations, which is biological change. Under this, we also have two subtopics, which are micro and macrobiological factors. Under microbiological, we have the most mentioned duo, bacteria and fungi, the latter consisting of yeast and molds. Bacteria are generally fastest growing, so that in conditions too favorable to both, bacteria will usually outgrow fungi. Under macrobiological, we have insect pests. We all know that we can never control how Mother Nature works. However, we can use insect repellents so that they would repel from the fruits or use temperature. Because did you know that insects won't be able to breed if the temperature increases 35 degrees Celsius or falls below 10 degrees Celsius? Now that I have finished my scientific explanations, let's head on to my experiment. In this portion of the video, I have conducted a 1 week research to show the day-by-day differences of deterioration and decaying within the normal room temperature and below 0 degrees, which is in the refrigerator. Let's go! Starting off my experiment with day 1. Now this is filmed on March 26, 2022, and let's head on to the Alagbati. Now, as you can see that we have a very rich and healthy alagbati with a lots of fruit, and you can also see bayabas and dragon fruit there, but that's irrelevant. Moving on, there are a lot of fruits here, and I have decided to choose these two types. Now, I have the reason why I've chosen these ones is because they look similar and you know they're same and they're easy to pull because it's not crumpled like the others. Now let's head on to our house. Now what I'll be doing is I'll be leaving one in the refrigerator and one up in my room. Now let's move on to putting one in the refrigerator. This experiment really made my day or somehow made me enjoy myself on liking chemistry more. Now as I leave this in the refrigerator, closing it onto the freezer room so that we will have 0 degrees or zero below 0 degrees temperature. And as for the other one, let's head on to my room. Now we're here, we're gonna leave it now. Thank you. And these are the pictures that I have collected. Moving on to day 2. Now day two's progress is a little bit weird because I didn't expect that the one that I left in the room temperature would become a little bit soggy. When I pressed it, it's not as hard when I used to on day 1, and it has a little bit stings. And now on the refrigerator one, this quite shocked me because I didn't thought that it would get harder or has a firmer state in mind. But that's what happens when you leave things in the freezer for too long. Things get hard. Now I've tried bouncing this, but there's nothing much really. Moving on, these are the pictures for comparison. Now let's head on to day 3. Now day 3 is quite a different thing. Not only my refrigerator has more food in it, but for the case of this berry or fruit in the refrigerator, it didn't really change for the past 3 days because you know what the refrigerator does or what the fridge does. And next, this happened to my berry that I have left on my room. Now it disassembled the part which shows that there is a seed in it and it has dried out because of the absorption within the room. Moving on to day 5. The reason why I don't have day 4 is because it's just the same. Nothing really changed much. So at this part of the filming or experiment, I think I've realized that these berries, as I mentioned in my physical changes, that there's nothing much change if there's no big of a size like these ones. And still, in my refrigerator, there's nothing changed there. Look, it's visibly the same. It's just cold. Yeah, and I'm bouncing it. Nothing really happened, just coldness. I've tried squeezing it also. It's hard. It somehow left out juices. Moving on to day 6. Now, day 6 is still the same thing, but I can feel the seed more now that most of the nutrients or juices have squeezed out to the fruit. And I've tried eating it and it's not a good taste. I have research on doing so and they said it was edible and not poisonous. It was bland and had a slight tasteless aftertaste. It's very hard when you touch it. Okay, moving on. Now we're on the refrigerator one. I don't think there's really much a difference now, unless I've concluded on other filmings. It really just shows that how much difference does it take when you leave things in temperature. Like when people, if you leave people hot-headed, they tend to get angry so much, and if you leave them very cold, they get alone. Excuse me. Now, let's move on to last and the day 7. Now, day 7 is the last approach, and I have concluded that I should plant these not only for the sole research of my experiment, but to also show the difference of what things happened. Now, for day 7, as per usual, nothing really changed for the refrigerator one. And as you can see there, there's still a juices. It's still healthy, looking good up until now. But let's move on to the dried or the left in the room one. Now, for this one, I haven't really thought of anything because it's still the same though. So there's nothing much to explain. And this was on this Wednesday, March 30th, the last day of my filming. And that concludes my experiment or my video. Thank you for watching, mom, and I hope you appreciate this documentary. Love you!